Warmest greetings to all my incredible subscribers and new viewers alike. Hello, fellow enthusiasts. Today, we're diving deep into the fascinating world of marine heatwave. Thumb up right world map showing several heatwaves at different locations in August and September 2023. The marine heatwave west of South America is a prominent example. A marine heatwave, abbreviated as MHW, is a period of abnormally high ocean temperatures relative to the average seasonal temperature in a particular marine region. Marine heatwaves are caused by a variety of factors, including shorter-term weather phenomena such as fronts, intraseasonal events 30 to 90 days, annual, or decadal 10-year modes like El Niño events, and longer-term changes like climate change. Marine heatwaves can have biological impacts on ecosystems at individual, population, and community levels. Views have led to severe biodiversity changes such as coral bleaching, sea star wasting disease, harmful algal blooms, and mass mortality of benthic communities. Unlike heatwaves on land, marine heatwaves can extend for millions of square kilometers, persist for weeks to months or even years, and occur at subsurface levels. Major marine heatwave events such as Great Barrier Reef 2002, Mediterranean 2003, Northwest Atlantic 2012, and Northeast Pacific 2013-2016 have had drastic and long-term impacts on the oceanographic and biological conditions in those areas. The term marine heatwave, referring to a discrete period of unusually high seawater temperatures, was coined following an unprecedented warming event off the west coast of Australia in the austral summer of 2011. The IPCC Sixth Assessment Report stated in 2022 that marine heatwaves are more frequent, more intense and longer since the ERS, and since at least 2006 very likely attributable to anthropogenic climate change. This confirms earlier findings, for example in the Special Report on the Ocean and Cryosphere in a Change in Climate from 2019, which stated that it is virtually certain that the global ocean has absorbed more than 90% of the excess heat in our climate systems. The rate of ocean warming has doubled, and marine heatwave events have doubled in frequency since 1982. Brace yourself for an in-depth analysis as we navigate through definition and its far-reaching implications. Thumb up right global marine heatwave MHW characteristics and case study regions. 34-year average properties of views based on application of the MHW definition to daily sea surface temperatures datasets. The IPCC Sixth Assessment Report defines marine heatwave as follows: the period during which water temperature is abnormally warm for the time of the year relative to historical temperatures, with that extreme warmth persisting for days to months. The phenomenon can manifest in any place in the ocean and at scales of up to thousands of kilometers. Another publication defined it as follows: an anomalously warm event is a marine heatwave if it lasts for 5 or more days, with temperatures warmer than the 90th percentile based on a 30-year historical baseline period. As we enter this new chapter, let's navigate the complexities of categories and unravel its multifaceted nature. The quantitative and qualitative categorization of marine heatwaves establishes a naming system, typology, and characteristics for marine heatwave events. The naming system is applied by location and year, for example Mediterranean 2003. This allows researchers to compare the drivers and characteristics of each event, geographical and historical trends of marine heatwaves, and easily communicate marine heatwave events as they occur in real time. The categorization system is on a scale from 1 to 4. Category 1 is a moderate event, Category 2 is a strong event, Category 3 is a severe event, and Category 4 is an extreme event. The category applied to each event in real time is defined primarily by sea surface temperature anomalies SSTA, but over time it comes to include typology and characteristics. The types of marine heatwaves are symmetric, slow onset, fast onset, low intensity, and high intensity. Marine heatwave events may have multiple categories such as slow onset, high intensity. The characteristics of marine heatwave events include duration, intensity max, average, cumulative, onset rate, decline rate, region, and frequency. While marine heat waves have been studied at the sea surface for more than a decade, they can also occur at the sea floor. As we progress, let's shine a spotlight on drivers and examine its intricate interplay within our topic. The drivers for marine heatwave events can be broken into local processes, teleconnection processes, and regional climate patterns. Two quantitative measurements of these drivers have been proposed to identify marine heatwave, mean sea surface temperature and sea surface temperature variability. At the local level, marine heatwave events are dominated by ocean advection, sea fluxes, thermal instability, and wind stress. Teleconnection processes refer to climate and weather patterns that connect geographically distant areas. For marine heatwave, the teleconnection process that play a dominant role are atmospheric blocking subsidence, jet stream position, oceanic Kelvin waves, regional wind stress, warm surface air temperature, and seasonal climate oscillations. These processes contribute to regional warming trends that disproportionately affect western boundary currents. Regional climate patterns such as interdecadal oscillations like El Niño Southern Oscillation ENSO have contributed to marine heatwave events such as the blob in the northeastern Pacific. Drivers that operate on the scale of geographical realms or the Earth as a whole are decadal oscillations, like Pacific Decadal Oscillations (PDO), and anthropogenic ocean warming due to climate change. Ocean areas of carbon sinks in the mid-latitudes of both hemispheres and carbon outgassing areas in upwelling regions of the tropical Pacific have been identified as places where persistent marine heatwaves occur. The air-sea gas exchange is being studied in these areas. In the upcoming section, we'll be shining a light on climate change as an additional driver. Thumbbrighter sea surface temperature from 1979 to 2023 in the region between 60 degrees south and 60 degrees north. Oldest years are blue, intermediate years are white, the most recent years are red. Scientists predict that the frequency, duration, scale or area and intensity of marine heatwaves will continue to increase. This is because sea surface temperatures will continue to increase with global warming, and therefore the frequency and intensity of marine heatwaves will also increase. The extent of ocean warming depends on emissions scenarios, and thus humans' climate change mitigation efforts. Simply put, the more greenhouse gas emissions or the less mitigation, the more the sea surface temperature will rise. Scientists have calculated this as follows. There would be a relatively small but still significant increase of 0.86 C in the average sea surface temperature for the low emissions scenario called 2.6. But for the high emissions scenario called 8.5, the temperature increase would be as high as 2.89 C. The prediction for marine heatwaves is that they may become 4 times more frequent in compared to under the lower emissions scenario, or 8 times more frequent under the higher emissions scenario. The emissions scenarios are called SSP for Shared Socioeconomic Pathways. A mathematical model called CMIP is used for these predictions. The predictions are for the average of the future period years 2081 to 2100 compared to the average of the past period years 1995 to 2014. Many species already experience these temperature shifts during the course of marine heatwave events. There are many increased risk factors and health impacts to coastal and inland communities as global average temperature and extreme heat events increase. As we enter this new phase, let's analyze list of events from different angles and evaluate its significance. Sea surface temperatures have been recorded since 1904 in Port Erin, UK, and measurements continue through global organizations such as NOAA, NASA, and many more. Events can be identified from 1925 till present day. The list below is not a complete representation of all marine heatwave events that have ever been recorded. Name category duration days intensity see Erin ref. Mediterranean 1999 181.9 NA Mediterranean 2003 to 10 5.50.5 Mediterranean 2003 to 28 4.61.2 Mediterranean 2006 to 33 4 NA Western Australia 1999 3 132 2.1 NA Western Australia 2011 466 4.90.9 Great Barrier Reef 2016 to 55 for 2.6 Tasman Sea 2015 to 252 2.7 NA Northwest Atlantic 2012 3 132 4.3 Northeast Pacific 2015 The Blob 3 711 2.6 Santa Barbara 2015 393 5.1 NA Southern California by 2018 344 3.9 NA Northeastern Atlantic 2023 534 5 NA. List of submarine heatwaves. Get ready to uncover the mysteries surrounding marine ecosystems as we navigate its intriguing terrain. Changes in the thermal environment of terrestrial and marine organisms can have drastic effects on their health and well-being. Marine heatwave events have been shown to increase habitat degradation, change species range dispersion, complicate management of environmentally and economically important fisheries, contribute to mass mortalities of species, and in general reshape ecosystems. Habitat degradation occurs through alterations of the thermal environment and subsequent restructuring and sometimes complete loss of begenic habitats such as seagrass beds, corals, and kelp forests. These habitats contain a significant proportion of the ocean's biodiversity. Changes in ocean current systems and local thermal environments have shifted many tropical species range northward while temperate species have lost their southern limits. Large range shifts along with outbreaks of toxic algal blooms has impacted many species across taxa. Management of these affected species becomes increasingly difficult as they migrate across management boundaries and the food web dynamics shift. Increases in sea surface temperature have been linked to a decline in species abundance such as the mass mortality of 25 benthic species in the Mediterranean in 2003, sea star wasting disease, and coral bleaching events. Climate change-related exceptional marine heatwaves in the Mediterranean Sea during resulted in widespread mass sea lift die-offs in 5 consecutive years. A news report. The impact of more frequent and prolonged marine heatwave events will have drastic implications for the distribution of species. As we transition, let's shed light on weather patterns and its relevance to our ongoing exploration. Research on how marine heatwaves influence atmospheric conditions is emerging. Marine heatwaves in the tropical Indian Ocean are found to result in dry conditions over the central Indian subcontinent. At the same time, there is an increase in rainfall over South Peninsular India in response to marine heatwaves in the northern Bay of Bengal. These changes are in response to the modulation of the monsoon winds by the marine heatwaves. In this section, we'll be shedding light on options for reducing impacts and its impact on our understanding of the subject. To address the root cause of more frequent and more intense marine heatwaves, climate change mitigation methods are needed to curb the increase in global temperature and in ocean temperatures. Better forecasts of marine heatwaves and improved monitoring can also help to reduce impacts of these heatwaves. Thank you for watching. I appreciate your support and I'll see you in the next video.